Hello, in this video we're going to talk about vertical shifts, and this is represented in exponential functions as a k-value. Can you please remember to go ahead and write down the objective today? Our objective for this lesson is students will be able to produce two exponential functions and then determine its vertical shift. For prior knowledge, we want to determine if a function is exponential growth, decay, or if it has a vertical stretch or compression. So looking at this problem, we've been looking at these two the past couple of days. Remember that we have defined exponential functions in the general form as a times b to the x, where a is our coefficient. So looking at this, the value multiplying out front is going to be our coefficient, so that's 0.3. The base, remember our base is always attached to our exponent. It's the base of the exponential function. So we would call this 12. So the base is 12. Now looking at these examples, the question says, I know this is exponential growth or decay. Well, the base value determines that. If I multiply a value times itself, is it going to grow or is it going to decay? Since my base is greater than 1, since 12 is greater than 1, I know this is exponential growth. Likewise with my coefficient, if I take 30% or 0.3 of an object, that's going to compress the object. This is vertical compression because 0.3 is between 0 and 1. 0 and 1. So that's your prior knowledge. Make sure you get those in your prior knowledge. So we've defined our exponential function as f of x equals a times b to the x power, and now we're going to add in this plus k. So make sure that you write this down somewhere. Remember that the a value is our coefficient that controls stretch and compression. The b values are base, and that controls growth or decay, if we're increasing or if we're decreasing. And besides my exponent, we now have this k value, which determines the shift vertically, up or down. It's kind of like the elevator. The k value kind of decides if your function gets in an elevator, if it moves up, or if it goes down. So please make sure you get that down. And I really highlight this fact. This is our new information today. The k value is the vertical shift. It controls if we go up or if we go down. So what I want to do is I want to explore with Desmos just to kind of give you a visual about this. Here I have my parent function is in the color black, and I have added this function here to control just to show you what the k value does. So notice my function is exactly the same, except this one, the red function, has a k value. So watch as my k value increases. So when my k value increases, the red function is going up. So k is 1, and I really want to point out here the intercepts. So notice the intercepts. This is how you judge your vertical shift and your k value. So notice that my intercept is 1 unit higher here. What happens if my k goes to 2? Well, then my intercepts here, 0, 3, 0, 1, notice it's 2 values higher. So the k value, if I add a value, say it could be, I don't know, let's make this 5. Well, how many units higher would you expect the intercept to be? Well, 5. It's adding a height of 5, and I can zoom out here and you can see that this k value, it doesn't alter it in any way, it just literally moves it up. Now what happens if my k value is negative? Well, you suspected it. The k value is decreasing, it goes down. So if k is positive, my function is being moved up on this wonderful Tuesday. And if my k value is negative, then it is going down. Okay, so that's kind of what the k value does. Feel free to play with this inside Desmos. I went ahead and I included the link here inside your Google Classroom, so you can follow this link, or if you see this here, you can copy in that link and play with this these sliders here with vertical shift. So back to our lesson. So a couple of notes. The first term I want to talk about is a constant value. When you add a constant value to a function, the graph undergoes a vertical shift. Please make sure you get that in your notes. So an example of this, if I have a parent function f of x equals 2 to the x, if I add 3, it's going to shift up 3 values. Additionally, if I add a constant value of -9, I'm taking away -9, my function's going to go down that many units. So if it's positive, we're going up on a Tuesday, and if it's negative, then it's going down. For real. Don't you love that? Okay. Next definition I want you to include in your notes, a vertical shift. A vertical shift moves the graph up or down depending upon the value added to the function. And we kind of just talked about that. Make sure that's added into your notes. And then a translation. This is connecting it back to our geometry unit when we talked about transformations. Remember, a translation's a slide. And we're only going to work with vertical slides. We're not going to touch the horizontal slides, okay? Again, remember that they don't change shapes. Nothing changes, it just moves it up. Please get these in your notes. Okay, so we're going to learn how to write a function rule for vertical shifts. And it looks kind of confusing. Notice that g of x here is on one side, and then I have f of x plus or minus k. This is how we're going to write these. Okay, so the first thing that we want to do, I want you to actually write this in your notes. Next to where it says given the graphs f of x and g of x, write a function rule for g of x in terms of f of x. Please write this down. So what we're always going to do, g of x is going to be our transformed function. And here I want you to, let me go back, I want you to notice that g of x is located here. This is my transformed function. Okay, so what we're going to do is we're going to go to f of x. So we're going to write g of x is equal to f of x. Okay, and if I'm at f of x, I want you to really draw the y-intercept. So draw that point, and then draw the point on g of x. So from f of x, how much do I shift up to get to g of x? Well, we go up 1 unit, 2 units, 3 units, 4 units, 5 units, 6 units. So g of x is really f of x plus 6, right? We just added 6. Make sure you get that. That's example number 1. Moving on to example number 2. Here I have f of x and g of x. So I'm going to write g of x. This is my transformed function. G of x is equal to, well, f of x. So here's my intercept. Now, how do I get from f of x to g of x? Okay, so hold on, pardon the sound. So in order to get from f of x to g of x, we're gonna count the units from intercepts. So up 1, 2, 3, 4. So always f of x to g of x. So we went up 4 units. So g of x is equal to f of x plus 4 units up. So we write the function like that. Okay, that's example 2. On the next one, I'd like you to try the next one on your own. Pause the video and see how you did compared to me. So go at this time, go ahead and pause this. Do number 3. Okay, so hopefully now you've had time to work this one out. Remember, the function rule is always g of x equals f of x. They want g of x written in terms of f of x. So g of x is f of x, but now what did we do? We went down 1, 2, 3 times. We went down 3, so it's going to be minus 3. Sorry for that curveball. Okay, but we went down, so that is subtraction. All right, for this next part, we are going to they want us to graph the function f of x and g of x and then state the vertical shift. So here, looking at our functions f of x and then g of x, you can already tell the k value. And here we can see that our k value is 3. So I have a k-value, a vertical shift of positive 3. Now, notice you have a table of values, and you have f of x and then g of x. What they want you to do is just plug in these x values into your function. So if I plug in 0 here for x, that is 4 to the 0. Anything to the 0th power is 1, and we'll talk more about this in an upcoming lesson, but that value is 1. If I plug in 1 here for my exponent, 4 to the 1st, this is 4, and then 2. If I plug in 2 for my input, I get 4 squared, and 4 times 4 is, that's right, 16. So that's our table of values. Now g of x, it's the same thing. Do you see this here? I'm going to get out of blue because I've already used blue. But do you see? I wanted to get out of blue. Red. Okay, here we go. So you see that 4x, it's the same thing, right? But g of x we just tacked on 3. So it's the same values, but we just add 3. So wouldn't g of x here be 3.0625? And wouldn't g of negative 1 be 3.25? Okay, so it's as easy as that. 1 plus 3 is 4. 4 plus 3, 7. 16 plus 3, 19. Okay, this is f of x, this is g of x. The last step that we need to do is just to go ahead and plot these. So negative 2, 0.0625, that's like way down here. Okay, next point, negative 1, 0.25, that's right here. 0, 1, 1, 4, and 2/16 way off the graph. So this is my function, and I hope you recognize this is exponential growth. And then I want to go ahead and plot g of x, which I'm going to do in red. So I have at negative 2, it is 3.625, that's just here. At negative 1, it is 3.25, which is here. 0, 4, 1, 7, which is up here, it's off the graph, and then 19, right, we're not going to reach. So my function should look like this. Right, it should look exactly like this function, but just shifted up 3 units, up 3. Okay, and that's how you do this example. I would like you to go ahead and pause the video now. I want you to try this one. Notice all the values are given for you. You just need to add in your vertical shift and then apply that to g of x. So go ahead and pause the video, do that now. Okay, hopefully you have identified the vertical shift. Notice it is a negative 2 tacked on at the end. My k value is a negative 2. So that shift is a negative 2, meaning we're going down 2 units. So negative 2, well, if I plug that into my function, I get 16. So this means I have 16 minus 2, that is 14. 4 minus 2, that's 2. 1 minus 2, negative 1. 0.25, take away 2 is going to be a negative 1.75. And then here, 0.0625, take away 2. Well, if you plug that in, 0.0625, take away 2, you get negative 1.9375. Okay, and it really doesn't want to write right there. Oop, there we go. Messing up on me. Okay, so last but not least, you just need to go ahead and graph these. So negative 2/16 is way up there. Negative 1, 4 is here. 0, 1 is right here. 1.25 and 2.625 is there. Okay, so this function, I'm going to try my best. There we go. It's not going that direction. It's going down. Okay, and then we plot our transformation. So this is this one. We're going to go shift down 2 units. So I'm going to label this. This is f of x, and then I have g of x. So negative 2, 14, I cannot fit. Negative 1, 2, that's right here. I'm going to get this guy out of the way. Next point is 1, negative 1,